Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks, depending on where you are logging in from. That'll sound just about right. Welcome to another episode of the 7 Signal Best Practices webinar series. As you guys can see, I've got Chris Mitten with me here today. I've also got Kelsey Rizzuto on the line with us. We're going to get started here in about 3-4 minutes. Got a great topic for you all today. We're excited to get it going. So if you guys don't mind, let's stick to our normal procedure here, and I'd love to hear about where you all are logging in from, and whether you're working from home or remotely. And I'll share it with the group here. Let's see, we, meaning Kelsey and I, are here in Cleveland, though I'm in the office, and she is safely social distance in her home. And Chris is joining us from Corpus Christi today, post-hurricane, and we were just talking about it, and sounded like things aren't all back to normal yet from a cleanup standpoint.
That's right, but we got the lights on, and most importantly, the air conditioning, so we're good to go. So yeah.
AC, yeah, can't live without that, buddy.
No.
Let's see. So we've got Mike in Vancouver at home. Welcome back, Mike. Olivier, welcome back as well, and British Columbia, working from home office. Paul, welcome back in southeastern PA. And I've got Beta in Ottawa, Canada. And Beta, I believe you are new to the group, if I'm not mistaken. Let me know. I don't recall seeing your name, at least in the last couple of weeks. He is also working from home. Thanks for letting us know that, folks, and thanks for dialing early here. Love our early groups that come through. We always get a nice number in. I'm always curious if that's because of the time difference. You're logging in outside the country, or if you're like me in that once that reminder pops up on from your calendar, I kind of forget it's there unless I click on that action. I log into webinars early all the time because I forget to do things. I'm super forgetful. So I've got 11 o'clock on the nose here on the East Coast of the US. So we're going to go ahead and get started. Welcome, everybody. Thanks for joining us today. We've got a great webinar topic for you all. For those of you who are not aware, my name is Don Cook. I head up marketing and channels here at 7 Signal. And with me today is Chris Mitten, one of our senior solutions engineers. And he's handling today's topic, understanding QoS in a multi-service WLAN. So really cool topic, lots to cover today. So I'm going to try and blow through some announcements and a little bit about 7 Signal. Just bear with me a few minutes here and we'll get to the meat and potatoes here. As always, our webinars are certified by CWNP. So for those of you looking to get any continuing education credits or a new certification, please let us know. We can drop you a certificate in the email, PDF. Super easy for us to do, and those will be good towards your CWNP certifications. We don't get into product tours on these Wednesday webinars, so for those of you who came to not only learn about today's topic, but also see a product tour, you're not going to see any product stuff from us today. This is purely educational. If you are looking for information about our products and services, you can go to go.7signal.com/tour. We have a product tour every Friday at noon Eastern time. No sales reps on the line, just me. So you get a marketing guy. Just me and Eric Muley, who's in charge of our customer success, and we walk through the products. So no hassle demo for y'all. As always, our webinars are archived on YouTube. So no need to email us or post a question in the chat about how to get a copy of it. Simply go to our 7 Signal YouTube channel and you can pull what you need from there. We also share the slides on Twitter for those of you who are following. And speaking of following, Kelsey's going to join us here in a second and let us know who last week's winners were to the trivia question. And I think we sent some swag to some new followers on Twitter too. Kelsey, is that right?
That's correct. So our winners from last week from Twitter were Jamie Franklin, Mike Dongvillo, and Olivier Gervais Harmon. And our trivia winners from last week were Terry Sawchuk, Stephen Coyle, and Corey Olson. So thank you guys so much for engaging with our webinars during the trivia portion, for following us on Twitter. As Dawn said, we post our slides after every single webinar, so go ahead and give us a follow. And we'll do the same thing this week and pick some winners for some 7Signal merch.
Yeah, awesome. Thank you, Kelsey. Olivier, I've heard his name several times on here. He's putting a major beating on my my budget. He's probably got a closet full of swag there. We got to get him some new stuff. We got to come up with some new gear. So cool. Thanks, Kelsey, for that. A little bit about 7Signal. The company was founded in 2007. We hit a lot of major milestones along the way. We're crunching a lot of KPIs, over 1 billion data points on a daily basis. We're on 5 million devices. We are GDPR compliant, so we make sure that we stay relevant with our privacy and technology stack at the same time. We've got 14 patents, 200 customers around the world, lots of partners who are on with us today. I saw a lot of names. We've got our Russian partners on, Comptech in Russia. I see we've got our folks on from the UK with Open Reality and others. So thanks for joining us today. Our partners are awesome. So why 7Signal is here? No one's come up with a perfect access point. No one's come up with that perfect device that runs perfectly in your environment. You need someone to come in, a third party to come in and make sure your end users have a quality digital experience. And that's why we're here. We've created a fully outside-in enterprise framework that's completely APN device agnostic, that's going to help you monitor the quality of your devices and the digital experience of your end users, completely outside in as part of our value proposition. And what we're looking for, what we call the top 7 Wi-Fi problems. These things present themselves differently to the end user and often to the help desk when they call in. It's my Wi-Fi is slow, unable to connect, but there's a root cause to it, and that's what we're getting to. And how we're doing it is we're running active and passive tests on the network and on the devices for things like packet loss, latency and jitter, MOS score, a full spectrum analysis with packet capture, things that your engineers need, your device teams need, or your help desk need to get to the root cause of an issue, to get your end users back to productivity, or your devices back to selling in a retail setting, or saving lives in a hospital setting. So we like to show this because it's a little bit easier to understand when you're looking at a traditional LAN infrastructure. So the folks in blue are what a lot of you, if you're not a 7Signal customer, enjoy now from your current vendors. Riverbed, Cisco, Aruba, Nianza, Atneta, SolarWinds, all live on the infrastructure, looking at your issues from the inside out. And there's great data that they are all able to pull. But what 7Signal does is we live on the edge or on those devices, monitoring the air between the devices and the access points with Mobileye. Any Mac, Windows, Android device, our Mobileye agent can be installed on, and making sure that those devices and the digital experience of the end user is optimal. Same goes for our sensor, our Sapphire Eye sensor that lives up in the rafters with the access points or down on a desktop, on a shelf, monitoring the quality of your access points. Looking at the RF, things that are invisible to the eye and things that your inside out infrastructure just can't see. So we're really here to complement the tools that you have on the infrastructure side. And that extends past just what you have with the enterprise and also includes those external networks. So again, you've got wonderful tools internally for your enterprise. Where 7Signal is coming in are those external networks, those home environments, apartment buildings, Starbucks. So regardless of where those devices are connected, we're able to look at those SSIDs and tell you what's going on in the environment at that time and tell you why the devices are having connectivity issues. Sometimes it's the device, sometimes it's the network. We help you get to that root cause quickly and easily. And with that said, we do have an offer that's still running due to COVID. This is our way to give back. For those of you who are struggling to support your remote workers, We are giving Mobileye away free for 50 days for up to 50 devices to help you troubleshoot. You can go to go.7signal.com/50 for 50. And we'll, Kelsey, if you could help me drop that link into the chat so everyone can access that who needs it, that would be excellent. And we've got two trivia questions for you all today. And you saw the swag that we're giving away, so hopefully you all can participate. I think the last couple weeks, although last week I think the group got a right answer. I think the last 2 weeks previous to that, we were struggling. Got a couple wrong ones. So let me launch this first question, and I've got two for you all today. These are compliments of Chris Mitten, by the way. So if you don't like the question, if they're too hard, you can complain to Chris after the fact. So here's the first one. Here's the first question we've got in. What year was 802.11e amended to the by the IEEE standard? We've got 2005, 1993, and 2015. And it looks like those questions are slowing down on the responses. A couple more laggards coming in here. Give it another few seconds, and then we'll close down this poll. All right, let me close this one out and share the results. And Chris, how did we do this time?
So I was going to give a few hints. It was the iPhone was new, Facebook was new, and Windows 7 was new. So the answer is A, 2005.
All right, well done.
Mm-hmm.
Well done. So Kelsey will go through and pick our winners for this week for that question. The first couple correct responses. So I'll hide the results and I'll pull up this next one and we'll get going here. This one's a little bit longer of a question if memory serves. Okay, which interframe spacing value is used for QoS data frames and is variable based on the WMM AC to which the frame is assigned? So that one's a little bit of a tongue twister, and I stumbled through that.
It's 50-50 chance.
50-50 chance, yeah. We made this a little easier on y'all. Let's give it another second or two here. We see the results coming through. All right, let's close it out there and share these. Chris, how do we do on this one?
All right, we got a good crew in here. The answer is arbitrated interframe spacing. So looks like the majority of people got it right. Yeah.
All right. All right, well, congratulations to you all. Chris, I'm going to hand you the controls here so you can share your screen and get us going.
Right on.
And I'll hide this, get that out of the way.
Okay. Let's see. Did you make me a presenter?
I did. Maybe I have to do it again here. Let's see. I'm going to take it back and then hand it to you again.
All right.
All right. Let's see what that did. There we go. Maybe the poll had something to do with that. Hang up. That's what we get for trying to be creative here.
Can you see my screen, Don?
I can.
You can?
Yes.
Perfect. Okay. We're halfway there. All right, everybody. Well, thank you very much. Bear with me. It's not letting me switch screens. Yep, there we go. All right, so the mandatory about me, I am a sales engineer with 7Signal. I am really excited to have this time with you guys today. I think this is a fun topic. This has been a topic that I have, as everybody in the business, have always been actually talking about, all the way back to my days before I went into the vendor space, where I was in charge of a lot like what you guys are today, a lot of our customers. Keeping the lights on for different companies and organizations, and QoS was always top of mind, all the way even back into early 2000s. So it's a great topic. And I'm super excited to be talking to you guys today. So this is the topic that we have today, understanding quality of service in multi-service wireless networks. Again, we have a nice little diagram that kind of gives a setting of what we're doing here, right? What it is before and without. And the topics we're going to cover real quickly is, really what is it? How does it work? Ways or traffic are prioritized, how it's used, some use cases, and more. And in my and more, I have all of my references and a whole bunch of additional information for you guys to hit and to look at that really expand onto this this presentation. And I also have a little note here that says to follow the yellow in this presentation. So let's get started. So when we talk about QoS, I'm going to define it by the CWNP, and they start off right off the bat as saying it's traffic prioritization and other techniques. I like that, other techniques used to improve end user experience. The second sentence, they mention the amendment, EEE 802.11e. So right off the bat, that shows you how important this is with QoS when it comes into Wi-Fi. And again, including QoS protocols for wireless network based on access categories. I have these guys noted because these are important as we talk about how actual QoS and Wi-Fi actually works. And this is the technical definition. And over here to the right is really how we all feel about QoS, that it's basically, almost just pointless, right? And I'm hoping here today to show you that there are actually some really good use cases for it.
Was that you last weekend, Chris?
Yeah, right. It felt like it, yeah. So when we talk about how quality of service works, we need to go to how collisions are detected and avoided. And this goes back to the very basics of the protocols, right? The Ethernet, which is wired, and the wireless, which is 802.11e. And you'll notice here that even with wired and wireless, that the way that the theory and the way that these actually stop collisions is completely different. And you're going to notice that as QoS comes into play, they start to follow those same paths. And the reason is because of obviously the physical medium, right? So wired, they can actually sense, right? They are in the collection detection business. Wireless, the medium, right? It's random, it's shared, and wireless is more focused on collision avoidance. And the biggest thing between the two is the wireless probability. So wireless in collisions, they work with probability. And you'll see this come into play as QoS gets developed into 802.11 standard with 802.11.e. And just in case everybody forgot what collisions looks like, I have this nice video that I could just watch all day. It's fantastic. Just love that video. That's literally a collision. So let's start at the beginning, right? So Wi-Fi collision avoidance, just as a quick briefer, right? This is 802.11 protocol. And you guys might remember the acronym DCF, right? Distributed Coordination Function. All that is that that's based on the carrier sense of making sure that that we don't have any collisions in the wireless environment. So we have in this function, we have interframe space, which is extremely important coming to QoS here in a second, back off timers. And again, this is frame by frame. So this is how it worked in 802.11 before 802.11.e. There really wasn't any QoS in this. And it really was on to diminish collisions, right? And so about that time, again, we're going to show two different groups working, that they decided that they needed to add some QoS features into it. And what I think the most elegant thing about this, and as engineers, you've got to really just kind of take your hat off, is how the engineers use the existing framework for collision avoidance and actually interjected with QoS mechanisms right into the same logic, which I think is really elegant. And so I'd like to share that with you guys going forward. So when we talk about QoS with wireless, it is the 802.11e amendment. And if you go to Wikipedia and you do a search for the 802.11e amendment, this comes up right off the bat. It's too technical for most readers to understand. Well, that might be true for the majority of people, but not us, right? Because we are seekers of truth. We like to dig in. So I thought that was really funny. That was the first thing that comes up is might be too technical to understand, but again, don't let Wikipedia scare you off. We got this, right? So once 802.11e came in around 2005 and got adopted into the standard, DCF, which I mentioned earlier, that was really focused in with a lot of things with just the carrier sensibilities of Wi-Fi, it was replaced with a very similar but very different acronym called Enhanced Distributed Channel Access. And when 802.11e came in, we had very specific changes or amendments to how this works. And we had two big ones. And the first one was EDCA, and the second one was WEM, or wireless multimedia. Now, you'll notice right off the bat that there are two different groups here. There's two different outfits. There was some documentation that they both were working on at the same time. They are independent of each other, but they both are used in the standard to actually have QoS work. And I will show you guys here how that works. We'll be referencing this diagram as we move along, and it's really cool how they set this up. So again, we were talking about enhanced distributed channel access, and we talked about interframe sequences. What 802.11e did was they modified and added two of these IFSs, these interframe sequences, and they added the one which was the trivia question, which was specifically on QoS, and that was arbitrated interframe spacing, right? AIFS. AIFS has contention windows with a minimum match we'll talk about, and then also priority queues. And again, what we're talking about is actually how Wi-Fi from a frame, again, this is layer 2, actually can prioritize traffic that it can't sense the collisions on, and it's all about the probability and how they added it to the standard. So with the addition of adding this AIFS, again, its definitions right here out of the textbooks. It's used for QoS data frames. It's variable based, which is important, based on the wireless multimedia access category. And access category, again, I've got highlighted for you because we're gonna reference that, and you probably already noticed in the presentations I've already shown little examples of that. It says before every frame transmission, so this is frame by frame, Wi-Fi stations select a random timer, which you guys are aware of, with the contention window range, and count down until the timer expires. Now how that looks like is this. So here again, here's our diagram, and I want you guys to notice the differences in size on these arrows here. Right here and right here. This is time, and this is frame by frame. And so what arbitrated interframe spacing functions as is that it shortens or expands the period of a wireless node that must wait before it can transmit the next frame. So there's our window, pun intended, right? The shorter the shorter arbitrated interframe sequence period means the message has a higher probability, again, probability of being transmitted with low latency, which is obviously important for video and voice. So let's dig into that just a little bit deeper. So what we're looking at here is the contention window, the interframe sequencing, and then also our our access categories. Now we'll talk about these acronyms here in a second, but what we just referred to is that we have interframe spacing. If you can notice, this is a little blurry, but this is an AIF, and you'll notice that it has a contention window of 0 to 15. This one has 0 to 15. This guy, 0 to 7, 0 to 3, and again, time. So these buckets here, what do these mean? Sorry, I hit the wrong button. Wait for it. So voice queue, right? So this means that we have a minimum and a maximum in milliseconds of this queue. You'll notice that the time block is actually smaller. So we have a minimum delay or send time of 3 milliseconds for voice traffic in the AIFS, right? In this bucket, which is the WVM. So as we look at these queues, so here's video, you have a minimum of 7, and then we have a best effort, and we have a background. This time difference is extremely substantial, and extremely substantial for voice. But what I'd like for you guys to, the main point of this whole presentation is to show you guys that how Wi-Fi QoS is actually implemented is that we use the the EDCA with the new interframe sequencing, with the arbitrator frame sequence. We actually set up queues, and we classify those queues based on the traffic, and then we reference the WMM profiles, and we add that traffic into those queues, and that's how we get what we consider QoS. One more slide here just to throw it in. So what we're looking at here is the same as we were looking at the previous slide, and now I have the actual names for these for these access categories, right? So what we talked about at the very beginning, and in fact, the CWNP definition of QoS actually even mentions the access categories in the second sentence of the definition. It shows you how important this is with WM, and what these are wireless multimedia access categories. So we have 2 different outfits, right? Wi-Fi Alliance, the IEEE, in the protocol or the standard 802.11e to actually work together with QoS. And again, this is layer 2. This is all frame. So this is what I think is really brilliant. I sometimes like to just look at the screen, especially thinking about how the way you could architect priority queuing in a medium like wireless, and they actually found a great, what I think is very elegant way to do this. So on the next screen, I wanted to show a picture of it. So since I work for this awesome company named 7Signal, I have access to Sapphire Eyes, and Sapphire Eyes can do Wireshark captures of any of the APs I have. And you'll notice here that I'm just did a Wireshark, and I just found one of the beacon frames for one of my access points here at my home office. And you'll notice down here that you will see those access categories. There's best effort, there's background, there's video, there's voice. Notice the minimum and maximums right there. They match up to what we talked about. I wanted to get into transmit opportunities, but was going to run out of time. So I put some reference documentation and architecture to go more into this. But this is really cool to actually see this in function. And I also referenced a video of it's a training video, an exercise, but they go into the Cisco wireless controller, and they actually disable and enable, and I believe there's one other feature of that version set of controller that was kind of like a little bit of WMM, but it was boolean. It was on, off, and then there was something like, I don't want to say maybe, but he actually in the video changes each setting and then does a capture to show you how different the traffic looks. We also have referenced architecture here that goes over some other vendors, but it's really cool to actually see it in action. So how does 802.11 QoS work? It works with the 802.11e amendment. So the enhanced distributed channel access works by placing frames, and I'm going to read this to you because it's so important. Different queues based on priority. The queues have priority from the lowest to the highest. Those queues are named background, best effort, video, voice. Obviously, voice frames has the highest priority, and background frames obviously have the lowest. Now, here's how it actually works. The priority is achieved by using different interframe, excuse me, I'm choking here, interframe space, specifically the IFS, delays for each access category by using a narrow contention window ranges for higher priority ACs. So that is a mouthful, but that is definitely how the Wi-Fi QoS works and how they solve that problem of implementing QoS into the existing way that Wi-Fi actually deals with collisions. And my favorite statement that keeps popping up in all the literature about when you talk about Wi-Fi QoS is this right here, and this great word, probabilistic priority. The result is a probabilistic priority mechanism that makes it right here more likely that voice frames will be transmitted before video before best effort before background. So Wi-Fi, right, they are in the collision avoidance business. They have to do this by probability. So QoS and Wi-Fi followed that same path, which was different than wired, and they're using basically probability. The more that you dig into this with the reference architecture that we talk about, you'll start to see that those are some of the issues that come up. And before I talk about the combination between the two, I just wanted to show real quickly, you know, why, or excuse me, how they both actually work together. So we've got wireless and we've got Ethernet. In wireless, it's usually the AP and the controller that oversees the tagging and the queuing. Again, it depends on vendor, it depends on setup, but usually that's the one that's in charge of it. It's also in charge of actually sending it across to the wired network and also from back. Now, I did this as a funny because this is probably why a lot of you guys are here today, is because end-to-end QoS from wireless to wired sometimes doesn't work. And I made it just like a small caveat, which it should be a big red flashing light, but that's like all the articles and all the research and release notes that we've done working on a project, kind of figure out why something can work. And then it never fails. There's a little asterisk at the bottom that says, oh, by the way, what you're doing, you know, won't work at all. And you're like, man, I've been you know, researching this for hours. So this small statement is the big reason why a lot of QoS end to end from wireless to wired doesn't work, is because of the tagging mechanisms. Wireless will tag something as voice going to the wired. Wired won't make that connection of what that traffic is tagged as, and will tag it as best effort. And if you saw in the diagram, if you have voice, which has a minimum of 3 milliseconds to fire, and it goes that way, but comes back as best effort or background, well, now it's got a 15, wireless sees it as a 15-second all the way up. And each vendor does this a little bit different. And in the architecture or the reference document, some of those links will actually show you how Aerohive does it, how Cisco does it, and how Aruba does it. It was too much to show for a quick presentation, but the vendors do some of their things, or how they match up wired and wireless a little bit different. And that's understandable because even the standard actually does it a little bit different. And there is even an RFC, which I have this here, and I also will have in the link, that try to address this. I don't believe it has been, it has gone anywhere. I think it's, I think the last was like 2018, but it's a really interesting read about trying to solve this problem. But just for an example, right? So we have the wireless QoS, right? 802.11e, and we have our access port categories, which are WMM. And you'll notice here, so like voice, right? So we can match that up, voice, but if coming back, got marked as backgrounds, got marked as background, we go from highest priority to lowest priority. So that is the main, well, one of the hardest things with doing end-to-end QoS. But if you're going to do a QoS environment, we get a lot of questions about why. And a lot of the best cases that we have, and again, this is in the reference architecture, is some of these new technologies, or these technologies that have been basically flashed to do a little bit different fulfillment, they really need QoS markings in wireless. IPTV over Wi-Fi networks is one. I think the biggest one is the single mode Wi-Fi phones. These are, you see a lot in healthcare and military. Wi-Fi location tags is a lot of asset tags, location type tags. Big into the space or the medical devices and obviously patient monitoring systems. They definitely need to have that quick priority, especially when it comes to voice. And then again, the proliferation of tablets and smartphones are brought into the use cases. So that was a mouthful. Here I have a link to everything that I had discussed, and it is a good starting point to digging in and learning more about how 802.11 and with the amendment of 802.11.e, and then with Wi-Fi Alliance, with the Wi-Fi multimedia, how they all went together and started to make a QoS environment, and how it is actually very much needed and how it is very much going to be required. So Don, that's really, I wanted to share so much more, but I wanted to be cognizant of time. So I'm going to pause for some questions, and I'll give you back control if you would like.
You can just keep it. We'll use your Q&A screen there, if you don't mind. Thanks, Chris. Wonderful job, right on time here. We're at just over 30 minutes in, so we've got enough time for questions here. Lots of comments. Great presentation, Chris, as always. And while you guys are typing your questions in, I'll catch up on my my shout outs from earlier. I saw at least one that I missed. Gustavo dialing in from Portugal. He says he's working from home. Welcome, Gustavo.
Cool.
And Mike says, Kelsey, you almost got his last name right when you were pronouncing the winners. So kudos to you for almost getting that right.
So close. I'll get it right next time.
All right. Sorry, Mike, you can only win one time. Just kidding. All right, so here's a question from Mike H. And you explained it maybe on the last slide. Maybe you want to touch on it in a nutshell. But does QoS apply to only Wi-Fi, or is it also applicable for WANs?
Yeah, that's a great point. And starting back in Don, I'll make sure that I won't talk for forever, because you know how I like to ramble on. It does. MPLS is a big part of QoS. There are a lot of SD-WAN uses a lot of functions on, software defined, has kind of morphed into QoS. I'm back from the days when it was IPsec. If we've got any route switch guys here, that was the start of it. So quality of service is, in theory, is supposed to be able to say, if I'm a voice packet from my phone and I'm going somewhere overseas, that I should get priority the whole way there. Well, that means that every device between here and there needs to be able to recognize that that's that traffic and prioritize it in the right queue. Now, like most good sales and engineering guys, I blame marketing for QoS, because sorry, Don, I do it every. There was that QoS was really gonna fundamentally change everything, and it was gonna be easy. It is actually very difficult to implement end to end, but yes, there are very much QoS, and you will find in your cable modems at home and in your small offices that you will see quality of service actually being used all the time. Especially even with Netflix, if you guys notice, with things like throttling down sometimes. So yeah, very much in use today, and will be used, and it's going to be that is going to be the way that things are done going forward. Is we're going to be very much more responsible and engineering more into the space that we have, right, instead of just throwing more bandwidth at it.
Mm-hmm. Thank you, Chris. Thanks for the question, Mike. Next one here is from Ahmad. It says, for wired QoS to kick in, the available bandwidth has to be overused. How does this happen in wireless?
That's right. That's a good question. So wireless doesn't work that way at all. So it is implemented and ready to go right off the bat.
Thank you. Next question thanks for the question, Ahmad. Next question from Michael Yu. Jumping a little ahead, my biggest question will be, how does Mobileye help us monitor and understand the WMM experience?
Ooh, that's a great question. That's a great question. So today, Mobileye doesn't have any application-specific information in it. So we just really see a lot in the RF space, but we haven't turned really anything on to show. So today, I don't see see a lot of it happening, but I could see in the future of actually showing some of that information, especially pulling out from some of the beacon frames that we have. That's a great question. That's a great thought too. I appreciate that one.
Thanks for that, Michael. Next one in here is from Mitch. It's a comment. He's saying CW aren't in milliseconds. That would be very long. I'm not going to go into the full comment here, but we'll leave that something, Chris, we can look at for the version 2 of this presentation.
Misspoke. Sorry. Thank you for that.
Keith, end-to-end QoS. There's a reason there's a book. Oh, I got it. So Keith is just saying end-to-end QoS, there's a reason there's a book for it. Most people don't understand that. So a general comment. Thanks for that, Keith. Let's see. The big problem with DSCP is that it had to maintain backwards compatibility with CoS classification. That was from Michael. Is that a comment, something you want to talk through, Chris? Can't really tell which ones are questions and which ones are just comments here, but.
Good comment, yeah.
Can you talk about upstream QoS for wireless clients? That's a question from Kenneth.
Yeah, so again, it's based on the markings of the IFS. So as long as you've got WBMM enabled on your access point in your controller, and that is it's being classified properly, you are getting the QoS that the standard is designed for.
Thank you. Question from Ahmad. Can Mobileye help with Android-based scanners? I'll just take that one. Thank you for that question. The answer is yes. And we're supporting versions 5, 6, 7, and 8, so up to Oreo. So depending on what version you're running of scanner, what devices. We're also ISV partners with SpectraLink, Honeywell, and Zebra, if that helps, Ahmad. A lot of great jobs for Chris. Let's see. Question from Nikita here. Where is the 802.11 QoS classification done? Is that something we can answer?
Is that a statement again? I don't know.
It's got a question mark after it. Where is the 802.11 QoS classification done? And he's got a follow up under it. Says both client device and AP. And that is also a question.
Yeah,
yeah.
Okay. Your application needs to be able to tag what type of traffic it is, and the WMM enabled. That classification then is tagged by the access point and the controller as into what queue it's done. The mechanism again is through the AIFS with the putting it into the priority queue of it being sent, probability of being sent out faster than other traffic on the shared medium.
All right, these guys are tough on you today. Let's see. Dave,
it's a very tough topic.
Yeah, we knew this was going to be a fun one. So Dave's got a question about AP switch port configuration. It says, would you recommend using L2, in parentheses, got 802.1p, or L3, which is DSCP, configuration? Does that make sense to you?
It does, and I'm going to say it depends on what the design is and what the AP making model and all that kind of jazz. I'll have to reach out to him and see what they're doing there, what the case study is for.
All right, I'll make sure you get that that question sent your way. See, we've got probably time for one more question, depending on, maybe two, depending on how quickly we can answer them. Let's see, question from Olivier, one of last week's winners here. Can you manipulate the vendor assigned QoS parameters, or are they hard coded?
The application can. Yeah, so the application actually can mimic the actual traffic if it's I have an example in the references, but it can be manipulated from the application, from basically the endpoint. And then in some vendors actually have the ability to change the marking strategy where you assign different values to different queues, and you can do that as well, where you can manipulate the traffic or even change the queuing priority for different types of traffic. We did it a lot with a product called Packet Shapers back in the day. It was a very interesting experience and fraught with peril.
All right. So why don't we do one more here? Look, and there's probably 6 or 7 that I'm not going to be able to get to just because of time, but we'll make sure that that Chris gets to these offline via email. But Pradala, I hope I'm pronouncing that correctly, is asking, how are RTP packets prioritized? And we'll close it down after this one.
That's a great lead in. That will be one that I would talk about ad nauseum. Let me take that one off to the side. I was thinking about actually doing the entire presentation on that.
Oh, well, maybe that's the sequel then to this one.
Yeah. Oh, if people especially want to keep going with this, this is a great a great dialogue to have because of the very nature of wireless, right? Of it's all probability, right?
Indeed.
So yeah, let me take that one offline.
All right, then why don't we shut it down for today? Thank you all for joining us today. We really appreciate seeing you all week to week. Chris, well done as usual. Enjoy the rest of your week, everybody. We'll see you all next week. Thank you.
Thank you, everyone.